Today, we're going to take a look at how to write a Fibonacci function. A Fibonacci series is a series that looks like this. 1, 1, 2, 3, 5, 8, 13, 21, and so on. So what's happening here? A Fibonacci series is defined as a series where the first two elements are 1 and 1, and all the elements following the first two are the sum of the previous two elements. So 2 is the sum of the previous two numbers here, 1 and 1. 3 is 2 and 1, 5 is 3 and 2, and so on. So if you were to mathematically represent this, it would look something like this. So f of n, which is the nth number, is f of n minus 1 plus f of n minus 2. So the nth number is the sum of the previous two numbers, and there's a base case which says f of n equals 1 for all values of n less than or equal to 2. So this is how a Fibonacci series is defined, and what we're going to do today is write a function that returns the nth Fibonacci number. So I'm going to use Python, and let's call the function f. So f of n, and it will return the nth Fibonacci number. So let's look at the base case first. So if n is less than or equal to 2, then you return 1, else you return f of n minus 1 plus f of n minus 2. Let's see if this works. So print f of 7, and let's run. So f of 7 is 13, and you can see that the 7th element is indeed 13. Let's increase this to 37, and let's find the 37th Fibonacci number. As you can see, it's taking some time to compute, and it's taken over 5 seconds to find the 37th number. One thing that I want to point out is this function is called a recursive function. A recursive function is one which calls itself. So f of n is calling it's calling itself with different arguments. So this is a recursive function, and the beauty of recursive functions is that they are very simple to write and to understand. So this is essentially this, and it's so easy. However, for certain class of recursive functions, they can be slow, and the reason why this function is slow is because of this. So what's happening in this case? So let's look at f of 7. What happens in f of 7 is this function calls itself with 6 and 5, and then 6 calls itself with 5 and 4, 5 calls itself with 4 and 3, and then it just goes on all the way to 3, which calls 2 and 1, and 2 and 1 are the base cases here, and they return 1. When 1 is returned, 3 can be computed, so that's 1 and 1, that's 2, and then 2 returns 1, so that's 1 and 2, and then the fourth Fibonacci number is 3 because it has that number, and then it goes up. But what's happening is that numbers are being computed multiple times, and I can illustrate that. So if we add something called a level, and let's add 1, so and level plus 1 and level plus 1. So what I've done is I've added this extra parameter to capture the level at which we are at. So this would be level 1, this is level 2, level 3, 4, 5, and so on. So if you run this now, print n and level. So if you run this now, you can see that 7 is called with level 1, which is here, 6 is at level 2, and then 5 is at level 3. So 6 calls 5, and this is level 3. So 7 calls 6, so it does this entire length down first, and then comes up does this, comes up, does this, comes up, and so on. So it does the left child first and then the right child. And so it's doing this 5. This 5 is calling 4, but it's at another level, so that's 4 at level 4, and then so on. And then at some point it does 3 at level 4, so that's 3 at level 4. This was level 5, so it's 3 at level 4, and then so on, and then it goes up. So if you look at the number of times these values are calculated, it's like 3 calls 2 and 1, 3 calls 2 and 1, 3 calls 2 and 1. So the same computations are happening time and again, and that's because of the way this function works. So can we make this better? What if we didn't have to compute the values again and again for the same number multiple times, but if we could just compute those values once? And that's what we're going to do. So let's introduce a hash map, and let's have the base cases here. So the base cases, Fibonacci of 1 is 1, the Fibonacci of 2, so that's the second Fibonacci element is 1, and then so on. So let's change this. So if m dot has key n, then return m of n. So what we're doing is we're checking whether the hash map contains the key, and if it has the key, it returns the value. And the base case is captured here, so it will work for the base case. And then for everything else, let's save. Let's first compute this value into a variable, and then let's save that here and then return the value. So what we're doing here is getting the value, computing it once, and then saving that into the hash map. So if I were to run this one more time, you can see that the call stack is much shorter and it's computing the values just once, and it's taken less time as well. So let's increase that to 37 and see how much time that takes. It takes 0.28 seconds, whereas previously it had taken 5 seconds. I can increase that to 77 and see how much time that takes. It took less than half a second, and if you had not done this, if you had done it the other way, it would have taken a very long time. It works for 177 as well. There you go. It's taken just over a second. So this is one way in which you can optimize a recursive function. There are a few other things that you could do. You could eliminate tail recursion, in which case the call stack would be, it would print the same way, but it would use less memory. One disadvantage of this is that if you have got very large numbers, it might run out of memory. Head recursion, or eliminating head recursion, will make it much more memory efficient. The other thing you could do to make it more memory efficient is to use an iterative function. So eliminate calls completely, and that works really well for a Fibonacci sequence. But this is optimal enough. The other two things will give you slight improvements, but for all usual purposes, this is good enough. Hopefully you've learned how to write a Fibonacci function and how to optimize it, and you've learned a bit about functions and how you can improve recursive functions. So that's it from me. Let me know how you liked this video in the comments below, and I'll see you next time with another video on how to write code. So until next time, goodbye.